Hello everyone. We will now begin our lecture on section 4 of chapter 8, which is on volume and surface area. So far we learned how to measure areas and find the perimeter of two-dimensional figures which had just the length and the width. When we talk about volume and surface area, there's going to be a third dimension added to the length and the width, and that is often the height or the depth of the object. So these measurements pertain to three-dimensional figures. So we will go into finding the area, well, not the areas, but the volume and surface areas of different three-dimensional figures like a cylinder, a cone, prisms, and then spheres, and so on. All right. So these are the topics that we are going to cover in this section. First of all, we are going to look at the formulas to determine the volume and surface area of rectangular solids, like a box is a rectangular solid, then cylindrical figures, conical figures, and spheres, spherical like a ball. All right, a ball is a sphere. And then we will look at the formulas to determine the volume of polyhedral prisms and pyramids. And then finally, we are going to solve problems involving cubic unit conversions. Let's first talk about what we imply when we refer to volumes and surface areas. The volume is the measure of the capacity of a three-dimensional figure. So if we have a rectangle with length and width, and we add a third dimension to it, then the rectangular figure, it becomes a box. And we can stuff things inside a box. A box can contain things. Now the volume tells us how much we can put into a box. All right. So volume is the measure of the capacity of a three-dimensional figure. Likewise, a glass has the bottom of the glass is circular, but the glass will also have a height, and because of that it can hold liquids perhaps, and how much the glass can hold, how much liquid the glass can hold, is measured in terms of the volume, and it'll be determined by the height of the glass, right? A glass which is a tall glass can hold, of course, a lot more liquid than a glass with a smaller height, correct? So that's what volume refers to. It tells us the amount of material, whether solid or liquid or even gas, that you can put inside a three-dimensional figure. The other term is the surface area. It is the sum of the areas of the surfaces of a three-dimensional figure. Right? It refers to the total area that is on the outside surface of the figure. So when we look at a box, so I'm going to quickly draw the figure of a box here. So just give me a second, and I'm going to make it a rectangular box. All right, so here is my box, and I'm not too good at drawing, but this is our box. All right, now this box has a top, it has a bottom, and then it has four sides, correct? Surface area is the sum of the area of the top, sides, the bottom, and then all the four sides put together. That's what the surface area is, and it refers to the total area. So we have to find the area one by one, first of the top, then of the bottom, and then of each of the four sides, and then add them all together to come up with the surface area. But that's only for a rectangular box. We will see how to find the surface area of spheres or cylinders, cones, and so on as well. All right. Now there's a special name for the study of three-dimensional figures, whether measurements or whether applications of three-dimensional figures. It's called solid geometry. So solid geometry is the study of three-dimensional solid figures, also called space figures. Now, the units of measurement for volumes of three-dimensional figures is in cubic units, so cubic feet or cubic meters or cubic centimeters as the case may be. But because there's a third dimension added when finding volumes, volumes involve three dimensions: the length, the width, and the height. The units of measurement is cubic units, whereas when we work with two-dimensional figures and we have to find the area of two-dimensional figures, the units is square units, so square feet or square meters or so on. All right, and then for surface areas, however, the surface areas of three-dimensional figures are measured in square units. So when we measure surface areas, even though it's on three-dimensional figures, the units are still in square units. All right. So here's a table with the different figures, three-dimensional figures, and then the related formula to find the volume. So these are all volume formulas, and then a picture, a diagram of what the figures look like. All right. So the first one is a rectangular solid, which is essentially a box-shaped figure. And to find the volume, the formula is length multiplied by width multiplied by height, right? So that measurement would tell us how much is the capacity of the box to contain, how much you can stuff into the box. So a rectangle has different measures for the length and the width as well as the height, right? So we have to take each of those different measures and multiply them to get the volume of the rectangular solid. The next one is a cube. A cube has all sides equal, all right? So it is a rectangular solid, but all the sides, the measure of the length, width, and height are all the same. All right, so all you do is it's still length times width times height, but since they are all equal, we can just multiply one side 3 times. So s times s times s, which gives us s cubed. So s being the length of one side. So that's the volume for a cube, and then we go to a cylinder. See, a cylinder has a circular bottom and then a height. So a glass is cylindrical. What's the formula for the volume? It's pi r squared h. Now, recall that pi r squared is the formula to find the area of a circle, right? So when we find the volume of a cylinder, all we need to do is multiply the area of a circle by the height of the cylinder. So pi r squared h is the formula. Then a conical figure, a cone, is 1/3 of whatever the formula for the volume is. So 1/3 pi r squared h. A cone will have a volume which is 1/3 of the 1/3 of a cylinder with the same height and the same radius. And then a sphere has volume 4/3 times pi r cubed. So to find the volume of a sphere, we multiply r by itself 3 times. So r cubed, so 4/3 pi r cubed. All right, so these are the formulas for the volumes of different three-dimensional figures. So now we'll go into the formulas to find the surface area of different three-dimensional figures. We start with the rectangular solid, which is essentially a rectangular shaped box figure. And remember that surface area is the sum total of the areas of all the sides of a rectangular box, so to speak. So this box has 6 sides, a top, a bottom, 2 sides to the left and the right, and then a side in front and a side on the back, correct? So 2 times LW, so the opposite sides of a rectangular box will have the same area, correct? So when we take 2 times L times W, so that's the area of the bottom as well as the area on the top when we multiply by 2. All right, so this will sum up the areas of the top and the bottom, and then we have 2 times WH, which would be the areas of the sides to the left and the right. W times H to find this area, and then we multiply that by 2 to combine the area on the left hand side, and 2 times LH. So LH would be the areas of the sides in the front and the back put together. All right, so when we sum them up, we get the surface area of a rectangular solid. Now a cube is also a rectangular solid, except that all the sides measure the same. The length, the width, and the height, they have the same measure. That's what makes a cube a cube. All right, all the sides are the same. So if we can find the area of one square, which is each side of the cube is a square, correct? So S times X will give us the area of one side, and there are 6 sides in a cube, so S squared multiplied by 6 would give us the surface area of a cube. Now for a cylinder, it's 2 times pi r times h plus 2 times pi r squared. Now pi r squared is the area of a circle, remember, and we have to multiply that by 2, and I'll quickly explain why that is the case. And then 2 pi r is the circumference, is the formula to find the circumference of a circle. Circumference means is analogous to perimeter, all right? And then if we multiply that by h, and then we add it to 2 pi r squared, we get the surface area of a cylinder. So in this figure, the cylinder is lying on its side, but let me draw a cylinder here, which is vertically up. So here we have a cylinder. A cylinder has a circular bottom and a circular top, all right? So think of a closed can, and then look at the surface of it. There is a circular top, a circular bottom, and then there is an area in between the two circles, in between the top and the bottom. So all of these added together would be the surface area of a cylinder. So we know how to find the area of a circle. We'll just multiply that by 2, all right, to get, and that's what we have here, 2 pi r squared. And then to find the surface area of the or to find the measure of the area in between the two circles, we take the circumference and multiply it by the height, this height, all right? So this will have a height, a cylinder has a height to it. So 2 pi r times h, which is the area in between the top and the bottom, and then to it we add the areas of the two circles. Again, this is a closed cylinder, all right? For the surface area of a cone, it's pi r squared. You see over here in this figure, the cone has a circular side, so that area is pi r squared. And then to find the area of this triangular part of the cone, it's pi multiplied by r, and then the square root of r squared plus 8 squared, all right? So for this formula, we'll just take it as it is, all right, because the explanation can be a little tedious and we don't need to know for the purposes of this course. Again, for exams, and for exams, yes, you will be provided a formula sheet. All these formulas will be given to you, provided to you, and you will refer to it to work on the problems. Finally, we have the surface area of a sphere, and that's 4 times pi r squared. Again, pi r squared is the area of a circle. You multiply it by 4 if it is a spherical figure whose surface area you are looking for. All right. So I'm not going to spend too much time on this particular slide. It just has all the diagrams, all the pictures of the different three-dimensional figures that we talked about, and it has the formula for the volume and surface area of each put together in one slide. All right, so instead we'll go on to the next slide and see, and we'll talk about some examples that we'll use finding the volumes and surface areas of different shapes. Now let's look at the first example to find the volume and surface area of a rectangular three-dimensional figure. And these are the measurements of each side given to us. The length is 10 feet, so it's important to mark the length, which is the length, which is the width, and which is the height. So 2 feet is the width, and this 5 feet here, this 5 feet is the height of the box, H. All right, so identify which one is the height, which one is the length, the height, which one is the width, which one is the length. All right, and so that we can plug in the correct values into the formula. So let's look at the solution. We have to find both the volume and the surface area. To find the volume, the formula is L times W times H. So essentially it's multiplying 10 with 2, which is the width, and then multiply that by the height, which is 5. So 5 times 2, 10. 10 times 10 would be 100. So the answer should be 100. But remember, volume has units in cubic feet, correct? These are all in feet. So you can either write it as feet cube or as cubic feet, cubic feet. So that's how you normally write the volume in units. All right. And the next one is the surface area. Okay, so it brought up the solution over my writing. So I'm going to erase my writing so we can see what the solutions they have provided. It's 10 times 2 times 5, which is 100 cubic feet. So feet cube. All right, so that's how we should write. Please do not write feet squared for volume. Feet squared is only for areas and surface areas. All right, so the next one is to find the surface area. Let's pull up the formula for that. It's 2 times LW plus 2 times WH plus 2 times LH. So 2 times LW is 2 times 10 times 2. So 10 times 2. That's the areas of the bottom and the top put together. And then we have 2 times 5. So that's 2 times 5 is this area of this smaller rectangle on the right hand side and the one to the left hand side, which we cannot see. All right, but it's the area combined, the two areas combined, and then the last one is the area of the top and the bottom. All right, the bottom surface and the top surface is 10 times 5. And then when we add all of them together, we have 160, but this time the units is feet squared or square feet. So this is cubic feet for volume and square feet for surface area. Now for the next example, it's on finding the volume and surface area of a cylindrical figure. So here are the measures given to us. They've given us the height of the cylinder, which is 7 inches, and the radius of the circular top of the cylinder, which is 3 inches, and that 3 inches would also be the radius of the circular bottom of the cylinder. All right, so determine the volume and surface area of the following three-dimensional figure. When appropriate, use the pi key on your calculator and so on. So let's review what the formula for the cylinder is. It's the surface area, well, for the volume, it's pi r squared h, correct? So for the volume, it's going to be V is going to be pi r squared h. So pi will of course be pi, and 3.1415 is the value for pi, and then r is 3, so 3 squared, and the height is 7, correct? So it would be 9 times 7, 63 pi, whatever that evaluates to. We have to use our calculators. And for the surface area, the formula is 2 times pi RH plus 2 pi r squared. All right, so 2 pi RH, just substitute the values of each of these variables. So it's going to be 2 pi times r is 3 and height is 7. So 7 times, so let's write it like this, 3 times 7 plus pi r squared is, let's do it step by step. So 2 times pi, and then r is 3 squared. All right, so that would give us 7 3s are 21 times 2, 42. 42 pi plus 3 squared is 9. 9 times 2, 18 pi, whatever that evaluates to, would be the answer for the surface area. So let's go on to the next slide, which will have the solutions for this. So you'll see here they work it out the same way as we did in the previous slide. They write the volume of the formula for the volume of the cylinder, which is pi r squared h. So pi times, they plug in the value of the radius in r, 3 squared times 7, which is the height, and then they evaluate that and get 63 pi, which comes to 197.92 cubic inches. All right, again, keep in mind volume to be represented in cubic units. Then we calculate the surface area. Formula is 2 pi times r times h plus 2 pi r squared, correct? So again, plug in the different values of the variables. 2 pi, and then r has a value 3, h is 7, and for the 2 pi r squared, r has a value 3, so 3 squared. For 42 times pi plus 18 pi, which is 60 pi, when you run that through your calculators, you should get a surface area value of 188.5 square inches. All right. Now this example is to find the volume and surface area of a conical three-dimensional figure. So the measurements given to us is that the circular part of the cone has a radius of 3 inches, and the height of the cone from its base or from the circular end to the bottom or top, based on how the cone is placed, is 7 inches. All right, so I'm going to go into the next slide where they show the solutions, how to work this out. But keep in mind that the volume of a cone is 1/3 the volume of a cylinder. So if a cylinder has goes by the formula pi r squared h, that's the volume of a cylinder. All right, it's a volume of a cylinder. Then the volume of a cone will be 1/3 pi r squared h, and that's always the case. This is the volume of a cone. It's just 1/3 of whatever the volume of a cylinder would be, with the same radius and same height. So first we'll find the volume of the cylinder. Again, the formula is 1/3 pi r squared h. We'll go in and plug in the appropriate values of the variables. R is going to be 3, so 3 squared, and the height is 7, h will be 7, so 3 squared multiplied by h multiplied by pi, and then we have to take 1/3 of it. So let's pull up the next part of the solutions. So 1/3 pi times 3 squared times 7 will give us 21 pi. All right, so when we evaluate that, we should get a value of 65.97, again, cubic inches. All right, as for the surface area, the formula is pi r squared plus pi times r multiplied by the square root of r squared plus h squared. So again, plug in the values. Pi times r is 3, so 3 squared, so that'll make it 9 pi. And then pi times 3 times square root over 3 squared plus 7 squared. So 3 pi times square root over 58, right? 9 plus 20, 49. 7 squared is 49. 49 plus 9 is 58. And then when we run it through the calculator, we should get a value of 100.05 square inches. All right. Now, the last three-dimensional figure that we will talk about before we go into a different set of three-dimensional figures is to find the surface area and the volume of a spheroid, a sphere, right? So determine the volume and surface area of the following three-dimensional figure. So let's go on to the next slide and go through the formula and the surface area calculations. However, just note that this the circular part of the sphere, or the circular part at the center of the sphere, has a radius of 6 centimeters. So now let's see how the calculation is done. The volume of a sphere is 4/3, 4/3 times pi r cubed. So we go ahead and plug in the values. Pi is a constant number, all right, but r has a measure of 6, correct? So it's going to be 6 cubed. And when we plug in the values, it's going to be 4/3 times pi times 6 cube for a calculated value of 288 pi, which approximately comes up to 904.78 cubic centimeters. As for the surface area, the formula is 4 times pi r squared. So again, plug in the values. 4 times pi times r is 6, therefore 6 squared, for a value of 4 times pi times 36, which is 144 pi, for an approximate measurement of 452.39 square centimeters. Here we have cubic centimeters, here we have square centimeters. Now we will talk about a more complex three-dimensional figure, which is a combination of other three-dimensional figures put together. All right, they are called polyhedra or a polyhedron for a single figure, for a single shape. It's a polyhedron, singular form, and the plural is polyhedra. It is a closed surface formed by the union of polygonal regions. So over here we have a cube. All right, this is a regular three-dimensional figure that we have already seen. Right, it has a vertex, and then vertex is the edge. All right, edge meaning the corner where different sides meet, the three sides meet. So that's the vertex, and the edge is one side, and then the face, which is the entire area on one side. Now, the polyhedra are these kind of figures that you see here. The first one, this green figure, is a pyramidal figure. So the base is a triangle, and then the other ends, all right, the other sides of this triangle are also triangles, all right? So the base is a triangle, and on top of it we place other triangles with a certain height. It's a pyramid, all right? Then for this brownish figure that we see, all right, next to the green figure, it's kind of like a pyramid over a pyramid. On the base we have a pyramid, correct? And then on top of it, we have another pyramid, which is of a different size, a smaller pyramid. This is also a polyhedron. And then over here, we have, um, it looks like a box, rectangular box, but you see, a rectangular box is even all the sides are of the same area, but this one has different lengths on top and may also be at the bottom. All right, so this is another example of a polyhedron. Now we'll talk about a formula derived by the Swiss mathematician Euler, which is applied on polyhedrons. And that formula says the number of vertices in any polyhedron, the number of vertices. What is vertex? Vertex is the corner of a figure where all the sides meet. All right, so let me write that down. The corner where all sides meet, or where three sides meet, so to speak. Let's put it that way, where all the sides meet. And when we say all, it means three sides meet. So the number of vertices in a polyhedron minus the number of edges. Edges are the sides, plus the number of faces. Now faces means surfaces, the number of surfaces, and that's how we distinguish between faces and edges. Edges represent edges represent an edge of the side, whereas surfaces is the flat part of a figure. All right, so number of vertices minus the number of edges plus the number of surfaces in a figure, in a polyhedron figure, will always equal to 2, no matter what shape polyhedron you are looking at. All right, so this is a neat formula that was derived by Euler, and he was a Swiss mathematician of the 18th century and the 1700s. Now let's discuss one polyhedron figure which is known as a prism. All right, so a prism is a special type of polyhedron whose bases are congruent polygons and whose sides are parallelograms. All right, so congruent means that the polygons at the base have equal sides, and the sides are, however, parallelograms. All right, what else? Let's see. These parallelograms or parallelogram regions are called the lateral faces of the prism. If all the lateral faces are rectangles, the prism is said to be a right prism. So let's see if we are provided with a picture of a prism, because just by reading the description it's difficult to envision what the shape may look like. So here are some figures of different types of prisms sitting on the bases, and you will see that bases are different polygonal shapes. So the first one on the left hand side, which is a yellow prism, it has a base. It's sitting on a base which is triangular. However, the sides, right, the different surfaces placed on it are rectangles. All right, they are congruous rectangles, right? There's the top base also, which is triangular. So we have rectangle, rectangle, and the bottom base and the top base are triangular. Then we have a prism, which is a cube, the green one here, and then the prism The blue figure is 1, 2, 3, 4, 5, 6. So it sits uh, uh, on a hexagon, right? It has 6 sides, the top and the bottom surfaces, and then there are rectangles uh, sitting between the two hexagons, right? And again, this orange one is sitting on a trapezoid, all right? And then again, the surfaces sitting on top of the trapezoid are rectangular figures. The top and the bottom are trapezoids, and the side surfaces are all rectangles, all right? So these are called prisms, where we have we have figures where the base is a certain polygon, and on top of it uh, the the sides are congruous rectangles. All right. Now, to find the volume of a prism, the formula is this uppercase B, and I'll tell you what the uppercase B represents. It's B multiplied by the height of the figure, all right? So this is an uppercase B. So far we have seen formulas like lowercase b times h and so on, right? The lowercase b, when it's the lowercase b, it is the length of a side, right? The length of an edge, so to speak. Whereas when we use the uppercase B, that means the area of the base. So the volume of a prism is given by the area of the base multiplied by the height. All right. So let's look into an example problem to find the volume of a prism. So here's an example to find the volume of a hexagonal prism fish tank. Frank's fish tank is in the shape of a hexagonal prism. Use the dimensions shown in the figure and the fact that 1 gallon equals 231 cubic inches to first determine the volume of the fish tank in cubic inches, right? So I believe there are more parts to this question, but we will begin by finding the volume of the fish tank. That means what is the capacity of the fish tank, how much water it can hold. So let's look at this figure over here. So we see that the base of the figure as well as the top of the figure is shaped as a hexagon. That means 6 sides, correct? And they have given the dimensions here. The one side of the hexagon is 8 inches. All right. So if one side of a figure, it's a congruent hexagon. Therefore, one side is 8 inches and all the other sides would also be 8 inches. And over here, the width of the object here is 16 inches. All right, from the one edge to the other is 16 inches, and the height of the tank from the bottom to the top edge is 24 inches. So given these measurements, the measurements of the different sides, let's see how we can answer the question to find the volume of the fish tank in cubic inches. So let's see how we can come up with a solution to solve this problem. We see here the fish tank has the base and then the upper end also in the shape of hexagons. All right. Now we do not have a specific formula to find the area of hexagons. However, if we split the hexagon from the center into 2 parts, we see that each part represents a trapezoid. And we do know the formula. We did learn how to find the area of a trapezoid. So this base, a trapezoid has bases of 2 different sizes. One base is the 16 inches. All right, we obtain the length of the base, bottom base is 16 inches, and the top base, and we are just concentrating on the trapezoid on top, all right, of this part. So 16, and then the base above, the side above that is 8 inches, all right, 8 inches, and the height of the trapezoid is 8 inches as well. So given that, let's look at the formula to find the trapezoid. So essentially what we will do is we'll find the area of this trapezoid, and then we will multiply that area by 2, which will give us the area of this entire hexagon, all right? And then we will multiply that by the 24 inches. But first, let's focus on how to find the area of the trapezoid. So area of a trapezoid is given by half the height multiplied by B1 plus B2. So B1 is this longer side, and B2 will be the shorter side of the trapezoid. So let's plug in the values now. We have half, which is a constant value, then H is 8, which is the height of the trapezoid, not 24 inches. That's the height of the entire tank. We're just focused on finding the area of the trapezoid at this point. So 8 inches, and B1 is this base, the longer base, 16, and then B2 is the shorter base, which is the one side of the hexagon, right? So when we do the calculation, we come up with a value of 96 square inches. So that is the area of just this top trapezoid. So we have to find the area of the bottom trapezoid, which will be the same as the top trapezoid. That's why we will just multiply the 96 by 2 to get the area of the entire hexagon. So that's what they do here. It's 2 times the 96 square inch, which gives us a value of 192 square inch. That represents the entire area of the base of the fish tank, the hexagonal base of the fish tank. All right. So now that we know the base, the area of the base of the fish tank, all we do is multiply the base by the height of the tank, and we should get the volume. All right. So let's pull up the solution here. So V equals uppercase B times H. We found that uppercase B was 192. Multiply that by the height, and we get a volume which is 4,608 cubic inches. All right. So for the next part of the question, we have to determine the volume of the fish tank in gallons. So we have found the volume in cubic inches, which was 4,608, right? 4,608 cubic inches, inches cube, which was the volume of this fish tank. However, this time they're asking what would be the volume in gallons. So we have to convert from cubic inches to gallons. Now we have been given the information that 1 gallon, all right, 1 gallon represents 231 cubic inches, all right, 231 cubic inches. Therefore, 4,608 cubic inches would be 4,608 divided by 231, which they have done here, and they came up with an answer of 19.95 gallons. Rounded to the nearest integer, that's about 20 gallons. Now, why did they do a division here? Why did they divide 4,608 by 231? Because 231 inch cube or cubic inches represents 1 gallon. So 1 cubic inch would represent 1 upon 231. Therefore, 4,608 cubic inches would be 1 divided by 231 times 4608. This is the unitary method you may have learnt in school, all right, but by the unitary method, we divide 4,608 by 231 to get our final answer. This is the process of conversion that we use, all right? Now we will look at a figure that's a pyramid. What is the property of a pyramid? It is a polyhedron with one base. So it has one base, and all but one face intersect at a common vertex. So you see over here that all these sides of the pyramid, they intersect at a common point up here, except the base at the bottom. All right, and that's true for all these different types of pyramids. All right, they except for the base, all the which is also a face of the pyramid, all the other faces, they go and converge at a single point. All right, so given that property, let's see how we can take measurements of a pyramid. Now the volume of a pyramid is given by the formula 1/3. Then here again we have the uppercase B multiplied by H. And what does the uppercase B imply? It means not just the length of the base, but the area of the entire base. Again, remember we are working with three-dimensional figures with which has multiple surfaces. So it's the area of the base multiplied by the height of the pyramid, and the height of any figure is always perpendicular to the base. So let's read through it again. V equals 1/3 B times H, where B is the area of the base. It's the area of the base, and H is the height. Now this example is to find the volume of a pyramid, and they've given us a picture of the figure. We see that the figure is a pyramidal figure, but it has a square base, and these are the measurements of the different sides of this figure. So the square base has one side as a 5, and if it is a square, you see they have, how do we know it's a square? Because they have indicated that these two angles are at right angles for these two sides of the square. So that tells us it's a square, so all its sides will have the same length. So if one side is a 5, then this dashed line will be a 5, then the opposite side to 5 will also be a 5, and so will be this measure here. And the height of the pyramid, which is from here all the way, so remember the height always has to be perpendicular to the center point, so it's always perpendicular. All right, so this isn't the height of the pyramid. The side of this triangle is not the height of the pyramid. The height will be from the center point of the square all the way up, rising perpendicularly. That means rising at 90-degree angle. All right, so the formula to find the volume is 1/3 B times H. We first have to find the area of the base, that means the area of the square, which is 5 squared, right? Area of a square is S squared. So 5 squared, so 25 square meters. And now we have to plug in that 25 into B, and then multiply that by 1/3 as well as the height, which is 6 meters. So 1/3 times 25 times 6 meters, which is the height, gives us 50 cubic meters. So this is the way we will be able to solve for questions on volumes or surface areas of different three-dimensional figures.